Every GnuPG identity is built on a key pair, two mathematically linked halves. The public key is an open padlock you hand to the world, used by anyone to encrypt a message to you or to verify your signature. The private key stays in your fist, secret and protected, and it's the only thing that can decrypt those messages or stamp them with your signature. A real GnuPG key isn't a single object, it's a tree. The root is the primary key, marked for certification and signing, and it never does day-to-day encryption. Branching off it are subkeys, separate cryptographic identities that the primary certifies and binds to itself. One subkey handles encryption, another handles signing. And because they're independent, you can revoke or rotate them without killing your entire identity. Fingerprints are the unique IDs of the crypto world. ASHA, one fingerprint is a 40-character hex string, short, widely used for quick comparison. ASHA, 256 fingerprint is a 64-character version, longer, more collision-resistant, and the modern standard. You exchange fingerprints out of band, in person, over a phone call, on a business card, precisely because they're the only way to be sure the key you downloaded is the key you intended. Signatures are how identity gets attached to keys. A self-signature is the primary key signing its own UID, a cryptographic receipt saying, this name and email really do belong to this key. A third-party signature is different. Here, Bob's key signs Alice's key, publicly vouching that he has verified her identity. One binds a person to a key. The other binds a person to another person through a key. Trust in OpenPGP isn't binary, it's a 5-level meter. Unknown means you've never decided. None means you explicitly distrust. Marginal means one or two signatures carry weight. Full means you trust someone's judgment completely. Ultimate is reserved for your own keys. The web of trust replaces the central certificate authority model with this mesh. Users sign each other's keys directly, and trust propagates through the graph. No single entity decides who you are, your peers do collectively. Inspecting a GnuPG key starts with a clean terminal workspace. We'll run a handful of standard commands to verify the installed version, enumerate keys and signatures, peek at the raw public key block, and confirm fingerprints, the canonical identifiers you actually compare when verifying someone's key. Before anything else, we clear the screen so every piece of output below is deliberate and easy to read. This is a small habit that pays off in any terminal session where you intend to share or reference the results. The first real diagnostic is GPG, version, piped through head -1 so we only see the top line, the version banner. This confirms GnuPG is installed and tells you the exact major and minor release you're working with, which matters because key formats and behaviors can differ between versions. Next, GPG list-sigs prints every public key currently stored in your keyring. Each entry shows the UID, typically a name and email, plus a long key ID. This is your inventory. If a key isn't here, GnuPG can't use it for encryption or verification. To see who has signed each key, we run GPG list-sigs. Signatures are how a web of trust is built. A signature from someone you trust is what makes a key trustworthy to you. The right-hand column shows short key IDs of every signer. Sometimes you want the raw key material, the armored ASCII block you'd paste into a file or send to someone. GPG, export, piped to head -5. Gives us the first 5 lines of that block, the header line, version, and the start of the public key packet. Finally, GPG, fingerprint prints the fingerprints for every key in your keyring in spaced, human-readable groups, exactly the form you read aloud or paste into a chat when verifying identity out of band. The fingerprint is a SHA hash of the public key, so two keys with different content will always have different fingerprints.